All right, April the 19th through the 23rd. This is lesson 29, applying tangents. We have been dealing with sine and cosine, so we're looking at tangents now. If you remember finding the tangent, according to the SOHCAHTOA, it is opposite over adjacent. I need you to pause for a moment and write these values down in your chart. What we did is we use a calculator to find these values, and you'll see that we have the sine and the cosine of our values, and then we did sine over cosine, which would be opposite over adjacent, and then we have our tangent. All right, so pause and make sure you have this written down. All right, so our goal today is to understand that the value of the tangent ratio of an angle of elevation or depression of a line is equal to the slope of the line. So we're going to apply what we know about tangents. All right, so B, the table from lesson 29 is provided here for you. In the row labeled sine of the angle over cosine of the angle, divide the sine values by the cosine values. What do you notice? Well, what you're going to notice for each of the listed degree values, dividing the value of the value of the sine of the angle by the corresponding value of the cosine of the angle gives us a value that is very close to tangent. Notice some of them are the same, but some of them might be just a little bit off. So we can say dividing the sine of an angle by the cosine of an angle gives us a value that is very close to the tangent of our angle. All right? It is very close. Now, you need to understand that sine of an angle divided by cosine of an angle is an approximation. The actual values might be exactly the same. Okay? So these are approximations. All right? So make sure you understand that. All right. So let's go ahead and look at, or let's do some discussion here. We're going to talk about tangents. And let me get a sheet of paper here. So we're going to do a discussion that ties together the concepts of the angle of elevation or depression in the real world sense. All right, and we're going to tie it to tangent and slope. So let's look at this diagram. Okay, so what this is it's steps. All right, so I've got person A here. Okay, and I'm going to put person B down here. All right, so the angle of elevation or depression is the angle between the horizontal or parallel with the Earth's surface and the line of sight. All right, so the line of sight for this person would be right here. All right? So this is the angle of elevation. I'm sorry, this is the horizontal. We're going to create the angle of elevation here. All right, so once again, the line of sight for this person, remember it's parallel to the Earth's surface. So this is the horizontal line that would be their line of sight. All right. So look at this. I can create this. All right, and this is their line of sight here. All right, this right here is an angle of elevation. All right, and we'll talk about why it's an angle of elevation. Because I am going from B to A. So elevation means up. All right, so I'm looking up. I'm going up. Their line of sight is going up. So this is the angle of elevation from B to A. I'm sorry, from A to B. I have that backwards. Sorry. All right. This right here is the angle of depression. All right. And this is the angle of depression of B from A. I've got this worded wrong. Hang on just a second. I'm getting myself kind of confused here. This is the angle of elevation. I had it right to start with. I just had it worded differently than I should have. This is the angle of elevation of A from B. So in other words, it's from B to A. All right? But we're gonna word it this way. This is the angle of depression of B from A. Okay? Because I'm looking down from A. So that is why it's called the angle of depression. Okay? So if I've got my horizontal and I'm looking down, that's an angle of depression. If I have my horizontal and I'm looking up, that is an angle of elevation. Okay? In this case, where two viewers can observe each other, such as the diagram here, what do you notice about the measure of the angles of depression and the angle of the measure of elevation? Well, you would notice if these two lines are horizontal, that means they're parallel lines, then you should notice that the angle of depression and the angle of elevation have the same measure. All right? Because I can use the line of sight as a transversal. All right? And in that case, that means these are alternate interior angles. So they do have an equal measure. All right, so let's kind of go on with example number 1. And this is going to use what we just talked about here. We're going to be using that line of sight and those horizontal lines. All right, Scott, whose eye level is 1.5 meters above the ground, stands 30 meters from a tree. The angle of elevation of the bird at the top of the tree is 36 degrees. How far above ground is the bird? Okay, so let's kind of draw this, or let's kind of label what we know. All right, so Scott, his eye level is 1.5 meters above ground. So that means that this right here is 1.5 meters. All right? It says he stands 30 meters from the tree. That means that this right here is 30 meters. All right? The angle of elevation of the bird at the top of the tree is 36 degrees. So, we're going to draw this horizontal line, which then gives him a line of sight to the bird. And now we have a right triangle. And it tells us that the angle of elevation, because we're looking up, is 36 degrees. All right? How far above the ground is the bird? Okay, so with respect of our diagram, let's think about what it is we are looking for. Let's go ahead and we'll label our triangle A, B, C. And we'll put the B at the top for bird. Okay, so what exactly am I looking for? Well, at this point in time, I am looking for BC. The reason is I know how far he is above the ground. Now I just have to figure out how far above his line of sight is from the bird. So I have to figure out this part right here. All right, so let's think about what we know. How do we find BC? Well, let's think about this for just a second. I know the measure of AC. If he is 30 meters from the tree, then I know that AC is equal to 30. All right? Which is the adjacent to my angle. The one I'm trying to find is the opposite to my angle. Opposite over adjacent is tangent. So I've got to do tangent of my angle would be equal to opposite, BC, over adjacent, which is AC. All right, and we're going to fill in what we know. So I know the tangent of 36 is equal to BC over 30. All right, now you can multiply both sides by 30. So now I have 30 times the tangent of 36 would be equal to BC. So that would tell me what BC is equal to. All right, so let's go ahead and plug that into our calculator. So I have 30 times, and I'm going to use parentheses and do, oops, sorry, tangent of my 36 degree angle all right, and that's going to give me approximately 21.8. And so I say that BC is approximately 21.8 meters. Now, I do not say it is equal because remember, this is an approximation. All right, so now we know that BC is 21.8 meters from his line of sight to the bird, or his eye level to the bird. So now, that's not telling me how far it is off the ground. So I now have to take that 21.8 and add it to the 1.5 meters that he is standing off of the ground. So when I do that, I get 3 3 3/10 meters. So the bird is 23 3/10 meters from the ground. All right. So we were able, so using the provided measurements that we have and the angle of elevation, we were able to use the tangent to find the height of the bird. All right, let's look at example number 2. Now, example number 2 is a real-world application. All right, it is talking about the angle of depression and tangent. So let's go ahead and look at what example number 2 tells us. From an angle of depression of 40 degrees, John watches his friend approach his building while standing on the rooftop. All right, so he's on the roof of his building, and he is standing there watching his friend. He can see his friend in a distance, and his friend is slowly approaching his building. The rooftop is 16 meters from the ground, and John's eye level is about 1 8/10 meters from the rooftop. What is the distance between John's friend and the building? All right, so I strongly suggest that you mark your diagram with the information that we know. Okay, so John, here's John. All right, this is his friend down here. So it tells me from an angle of a depression of 40, so we're looking from John down. John watches his friend approach the building while standing on the rooftop. The rooftop is 16 meters from the ground. All right, so I know that this is 16 meters. Now, we're going to look at John's line of sight, or his eye level. All right, there's his eye level. Now, the line of sight is a depression. So that means we are looking down. All right, so here we go. We have our right triangle here. All right. And it says this is an angle of depression of 40 degrees. Okay. So let's see. We've got the angle of depression, 16 meters from the ground. John's eye level is at about 1 8/10 meters from the rooftop. All right. So his eye level is about, so this right here is 1 8/10 meters. All right, 1 8/10 meters. So let's talk about what we know now. His friend, we are trying to figure out what's the distance between John's friend and the building. We want to know what this is. All right, so let's go ahead and label this A, B, C. We are trying to find BC. We want to know how far is his friend from the building. All right. Now, what do I know about this right here? Well, I know that this is 16 meters, and then I know that we have to add another 1 8/10 meters to that to get this whole entire thing. And really, I guess I should have drawn it like this. I should have gone all the way to the ground there. So now I know that this right here is 17 8/10 meters. All right, 16 plus 1 8/10 meters. All right. So let's look at what we know. I'm trying to find BC, which is my adjacent. I know my opposite. So we know that we're going to use tangent. So we're going to do the tangent of a 40 degree is equal to, so tangent is opposite, so BA over hypotenuse. I'm sorry, opposite over adjacent. So BA over BC. Okay? All right, let's fill in what we know. Tangent of 40 is equal to, I know BA, so that's 17.8 over BC. All right? So now, how am I going to solve this? So I would multiply everything by BC. And I know, hopefully, you can figure this out without having to write down every single step. So I get BC tangent of 40 is equal to 17.8. I want BC by itself, so I need to divide by tangent of 40. So then that gives me BC is equal to 17.8 over the tangent of 40. Alright, so let's go ahead. We're going to go to our calculator. And I'm going to do 17.8 divided by the tangent of 40, which gives me approximately 21.2 meters. Alright, so I'm finding this right here. He is approximately 21 2/10 meters from the building. Alright? I don't have to go any further with that because that's how far he is from the building. Alright, let's look at exercise 1. Standing on the gallery of a lighthouse, the deck at the top of the lighthouse, a person spots a ship at an angle of depression of 20 degrees. The lighthouse is 28 meters tall, and it sits on a cliff 45 meters tall, as measured from sea level. What is the horizontal distance between the lighthouse and the ship? Sketch a diagram to support your answer. Alright, so I'm not dealing with a human here. Alright, so we've got to look at, when we talk about line of sight, we're not talking about a human's line of sight. We are now looking at the ship. Okay, so it talks about the gallery or the deck above or at the top of the lighthouse. All right. So I guess really it does say a person. So the person is assumed to be at the lighthouse. All right. So the person's line of sight, which we don't know exactly where that person is, but the person's horizontal is here. Alright? And it says that we are dealing with a depression of 20. A depression means we're looking down. And it says we're looking down at the ship. Alright? Which means here is my right triangle. Alright, we are looking down at a depression of 20 degrees. Alright, so then let's talk about what we know. It says that the lighthouse is 28 meters tall and sits on a cliff that is 45 meters tall. So, if the cliff is 45 meters tall and the lighthouse is 28 meters tall, then how tall is this side here? Well, we would do 28 plus 45, which tells me that this is 73 meters tall. All right? What is the horizontal distance between the lighthouse and the ship? So we want to know what is this right here. So once again, looking at this, I'm trying to find the adjacent. I know the opposite. Opposite over adjacent is tangent. So I'm going to do tangent of a 20 is equal to, we can label these A, B, C. So the tangent of my 20 is equal to opposite, which is BC, over adjacent, which is AB. So I have tangent of 20 is equal to, I know what BC is, that is 73, and I'm trying to find AB. All right. So if I multiply both sides by AB, I end up with AB tangent 20 is equal to 73. I'm going to divide by the tangent of 20. So I get AB is equal to 73 over the tangent of 20. All right, so I'm going to go to my calculator, and I'm going to do 73 divided by the tangent of 20, which gives me that AB is approximately, and round this to the nearest meter, that's fine, 200.566, which would be 201 meters. All right, so it is approximately 201 meters from the shore. All right, let's go ahead and look at example number 2. Let's do a little bit of discussion really quickly. Because exercise number 2 deals with a piece of graph, or dealing with graph here. Okay, so let's examine the angle of elevation and depression on a coordinate plane. All right. So let me really quickly draw you a figure here. All right, so so let's say, let me get my straight edge out here so I can make sure it's, all right, so looking at this, what kind of slope do I have? I know nothing at all about this line that I just drew, except by the direction that it is traveling, I know that it has a positive slope. Okay? I know it has a positive slope. And I also know that it does cross the x-axis. All right? So now, I want to know what kind of angle it has. Well, with it having a positive slope, this would be an angle of elevation. Positive slope means I'm looking up, so it is an angle of elevation. Notice that the slope of the line is the tangent of the angle elevation. Why is this true? Well, by building a right triangle, so that one leg is parallel to the x-axis. It's parallel to the x-axis. Here's my leg that's parallel. And the other is parallel to the y-axis. All right. So here's my other leg that's parallel to the y-axis. Around any 2 points selected on the line, we can determine the slope by finding the value of rise over run. Guys, rise over run. Rise over run. This is, so here's my rise, and here's my run. Think about this in terms of my angle. This would be my opposite. This would be my adjacent. We find slope by saying rise over run, which is also the same as saying opposite over adjacent, which is tangent of our angle. Okay? That's why when I have a positive slope, I can use my tangent. All right? Let's look at what happens if we have an angle of depression. All right, let me flip my paper over here and get some more room. All right, so let's go. All right, let's look at this. All right, so here's this line. Now, once again, I know nothing about this line except for what kind of slope do I have? Well, this is a negative slope. All right, this is a negative slope. So here's where I would see an angle of depression. All right. Notice that the tangent of the angle of depression will be positive. To accurately capture the slope of the line, we must take the negative of a tangent. Because think about this, guys. We have a negative slope, so in order to, when we find our tangent, it's positive, but in order to find the slope of my line, it would be a negative. We'd have to take the negative of the tangent. All right? All right, so let's look at exercise number 2. A line of the coordinate plane makes an angle of depression of 36 degrees. Find the slope of the line, correct to 4 decimal places. Okay, so we can do tangent. All right? So looking at our tangent, that would be opposite over adjacent, or M over N. All right? So tangent of 36 is equal to M over N. All right? Now, so all I have to do is find what my tangent is of 36. So tangent of a 36-degree angle and it says go to 4 decimal places, 0.7265. Now, remember, because this is an angle of depression, I have to take the negative of that. So the negative tangent of 36 would be approximately negative 0.7265. So the slope of my, this is the slope of my line. All right? All right, so the slope of a line increasing to the right is the same as the tangent. The slope of the line decreasing to the right is the same as the negative tangent. All right, so if I have a negative slope, I have to take the negative tangent. If I have a positive slope, it's the slope of my line is the same as the tangent of my line. All right? All right, guys, that is the end of lesson 29.